Okay, 6.4 notes. Oops. We're going to talk about the dot product today. So we can take the dot product of two vectors. Our dot product formula is this. So we multiply the first two terms together. So the first times the first plus the second times the second. The dot product, when you take the dot product of two vectors, your answer is going to be just one number. So the dot product, the answer is just a number. That's probably the most common mistake that people would make, is that they multiply the first times the first and the second times the second, but they leave it as a vector. So when you take the dot product, your answer is just a number. So we have a few properties for dot product. You can take the dot product of u and v, which would be the same thing as v and u, so the order doesn't matter. For number 3, if we had 3 vectors, you could either add the two together, so do the parentheses first, and then take the dot product of u with that, or you could take the dot product of u with v and the dot product of u with w, and then add them. So the order doesn't matter there either. If you were multiplying the dot product by a scalar, you could multiply the scalar to both the vectors, actually just to one vector first, and then take the dot product. So either one. I would just say take the dot product first, then multiply your scalar. So just follow your order of operations. If you have parentheses, I would do that first. And then if you take the dot product of the 0 vector, so that bold 0 is our 0 vector, which is 0, 0. With any other vector, your answer is going to be just 0. And then if you take the dot product of a vector with itself, your answer would be the magnitude squared. All right, so let's apply these in some examples. So example 1, finding the dot product. So to find the dot product, we multiply the first number with the first number. So we would get 4 times 2, which would be 8, plus the second number with the second number. So 8 plus 15, which would be 23. So let's look at B. We multiply the first times the first, so we would get 2, plus the second times the second. So negative 2. What do we get? 0. And then for C, first times the first, which would be 0, plus the second times the second, negative 6. So what would our answer be? Negative 6. Perfect. All right, in example 2, again, we're finding the dot product, but we have more properties, more operations going on. So for A, we have to find the dot product and then multiply that to our vector w. So let's start with finding the dot product of u and v. So how do I find the dot product? First times the first, plus the last times the last. So negative 2 plus negative 12, which would be negative 14. So then I have negative 14 times vector w, which is 1, negative 2. So how do I multiply a number, a scalar, to a vector? What would I do here? How? Distribute, yeah. Multiplies each number, perfect. So here's one of those examples where my answer would actually be a vector, because we're multiplying the scalar to the vector. So it would be negative 14, 28. All right, let's look at B. So I have u and the dot product of 2 times v. So what do you think I would have to do first here? I got to distribute the 2 to v. So I'm taking the dot product of u, whatever 2 times vector v is. So that would be 2 times 2, negative 4. So we distribute. So we would get 4, negative 8. And then I have to take the dot product with u. So negative 1, 3. How do I take the dot product here? First times the first. What would come next? Plus the last times the last. So negative 24. So what's negative 4 plus negative 24? Negative 28, and that would be our answer. All right, C asks us for the magnitude of u. Remember, these double bars are the magnitude. So what's our magnitude formula? Anybody remember? Well, when it gives us the vector, it's the first number squared, so negative 1 squared, plus the second number squared.
Wait, so when would you use?
So we would have the square root of 1 plus 9, which would be the square root of 10. All right, next thing we're going to be able to find is the angle between two non-zero vectors. So if it gave me two vectors of u and v, I can find the angle in between using the formula on the next page. So this would be our formula. So you need a calculator for these, but we would have to find the dot product, so u dot v over the magnitude of u times the magnitude of v. And that would give us cosine of theta, and then we would have to use second cosine to find what the angle is. So we have to know what the dot product is and the magnitudes of each vector. So in example 3, it says find the angle theta between u and v. So our formula is cosine of theta is equal to the dot product, so u dot v over the magnitude of u times the magnitude of v. So I need to find three things first: the magnitude of u, the magnitude of v, and the dot product. So let's start with the dot product. How do I find the dot product? First times the first plus the last times the last. So this would give us 27. Next, let's find the magnitude of u. So the magnitude of u would be the square root of what? 4 squared plus 3 squared. So the square root of 16 plus 9, which would be the square root of 25, which is 5. So I'm going to plug these in so far, but I still have to find the magnitude of v. So I have 27 over 5 times, still got to find the magnitude of v. How would I find the magnitude of v? The square root of 3 squared plus 5 squared. So this would be 9 plus 25, which would be the square root of 34. Now you don't have to simplify the square root here because you're going to end up putting this all into your calculator. So we're going to put this into the calculator. So when we put this in the calculator, we should get 0.926. So how do I find what just theta is? Awesome. I got to take the inverse cosine of that. So I would click second cosine of that number, and we should get theta is 22.14. Close to that. I rounded in my calculator, so I might be a couple decimal places off. We could say 22 degrees. So we do the inverse cosine of 0.926. Put that in the calculator. Okay, so still talking about the angle between two vectors. We have this word called orthogonal, which is just the same as perpendicular. It's like when two vectors are perpendicular, it's called orthogonal. So it means the same thing. Two vectors are orthogonal when the dot product is 0. So to figure out if two vectors are orthogonal, it'll give us two vectors and say, are they orthogonal? You just have to take the dot product of them. If your answer is 0, they're orthogonal. If it's not 0, then they're not orthogonal. So example 4, are the vectors orthogonal? So what do we need to do? Take the dot product. Perfect. So we got to take the dot product of u and v. How do I find the dot product? First times the first, so 12, plus the second times the second, the last times the last. So 12 plus negative 12 is 0. So are they orthogonal? Yes. The next slide just talks about two orthogonal vectors. So two vectors that are perpendicular are vectors that meet at a right angle, which are orthogonal. Two vectors are orthogonal if and only if the result of their dot product is 0. So we just said that on the last slide. But we can also have parallel vectors. So orthogonal means that they are perpendicular, they meet at a right angle. But parallel would mean that they don't intersect, that they would have the same slope. So two vectors are parallel if and only if they are proportional. So you would set the first number over the first number of the second vector and see if that's equal to the second number over the second number in the second vector. So the first over the first has to be equal to the last over the last. Just make sure you keep the same proportion. If two vectors are orthogonal, could they also be parallel? No, it can't be both. So if you find out that one's orthogonal, you don't also have to set up a proportion. They could either be one or the other, or they could be neither. So just keep that in mind. So let's look at example 5. So example 5, it asks if we have parallel, orthogonal, or neither vectors. So here vectors are written with I and j. If we put this into component form, how would I write my vector here? 2, negative 2, perfect. And what would my other vector be? Negative 1, negative 1. Awesome. So first let's see if they are parallel. So to determine if they are parallel, we need to set up a proportion. So we would say the first number over the first number, and that has to be equal to the second number over the second number. So we get negative 2 is equal to positive 2. Is this true? Nope, so they are not parallel. Now let's see if they are orthogonal. How do I figure out if they're orthogonal? We got to do the dot product, so u dot v. So the first times the first, we get negative 2 plus the last times the last. So that would be positive 2. Negative 2 plus positive 2 is 0. Are they orthogonal? Yes.